Welcome to this presentation. We will be considering the modeling, load calculation, applying the load analysis, and design of this reinforced concrete tank stand. And it is going to carry a tank capacity of 10,000 liters of water. Alright, I'm so freezing. Don't forget to like and subscribe to Soft Freezing channel and stay tuned for more advanced lesson. And also, if you have any comment in this respect, also drop it at the comment sections as we will make progress into the lesson. I will be taking you to AutoCAD so we can actually look at the plan view of this and the dimension, because that is where we are going to be setting out our grids from. So here is the dimensions of the reinforced concrete platform, this one, as well as the columns. So you can see the column is 250 diameter, ROC columns, okay. This is ROC slab 185 millimeter thick, right? And then for the tank itself, each of this tank is 2500 liters water tank, okay, just like this, and then into 4, so 2.5 into 4. All right, so we have 10,000 liters, okay, of these tanks. When we come back for the loading calculations, after we must have finished the modeling, so we'll be referencing this to model in Protastructure. All right, and so we are using Protastructure version 2022 for this course. So let us get started for the modeling. We are going to start by creating a new project. And so we will navigate to new right there. This one, click on new right there. So this is ROC tank stand. Okay, so I will just add 10,000, just like that. ROC tank stand. So we will be considering BS 8110 as the template. Okay, click on the okay options. Okay, yeah, the template is ready. So when we start the Gridline setout, we will be able to import it from Protastructure successfully, but for the sake of learning, we will have to set out the grid using the Orthogonal Axis Generator method of Gridline setout for our structural column placement as well as the beams successfully. Okay, so for us to do that effectively, we will be minimizing this window so we can interact both in AutoCAD and as well in the Protastructure 2022. So let's do that. Alright, so this is what I actually meant. So with this now, we can now start the modeling successfully. We'll navigate to the modeling tab right there, and then we will be considering under grids right there. You have orthogonal, this one, Axis Generator. So you click on it once. So once you click on it, you have to pick an insertion point. So I will be starting it from here. I pick that point as my starting point. So I will have an orthogonal axis generator dialog, just like this. Okay. So in this dialog now, you should know that the direction 1 axis is the alphabetical axis, okay, which is labeling from A, B to Z, right? While the direction 2 axis, and this axis you see here is the horizontal axis, okay. All right, while the direction 2 is the vertical axis, which is leveling alphabetically. All right, okay, so what we have here in the direction A, which is the horizontal axis, we have the first we want to be looking at the important grid lines. Okay, the important grid lines are the grid lines 1, okay, grid line 1, 3, 4 and 6. Okay, these are the important grid lines we need, you know, to key in over here. So in that directions, which is the horizontal directions, we are to consider grid line A, and the space between grid line A and grid line C is what? 963. Okay, so you have to key in 963 right there, just like this, and then you put a comma right there. So the spacing between Gridline C and then E is 1200. Okay, so you key in 1200, sorry, that is 1200, just like this. Okay, then comma again. So, and then the next provision is also 9 6. Okay, 3. So you key in 9 6 and 3. That is that in that directions. Okay, so we are not considering this axis level 2 and as well as axis level B. Okay, we are not considering that in this particular provision because we don't have need for that. All right, so coming to the direction 2, which is the vertical directions, we are still having the same thing. Okay, so we can decide to copy what we have here. You can do Control C on the keyboard and then you try to paste what you have there. You can see. Okay, so this is it. All right, so this provisions where we have the 2000 millimeter is the axis extensions length. Okay, so the axis extension length, you can adjust it or you can leave it the way it is. And then where we have this reference point X 5000 is just the reference point from the UCS icon, universal coordinate icon. Okay, so just click on the OK options. Let's look at what we did. So this is what we did and this is what we are having. Okay, so you can see A, B, C and D. Okay, so we omitted all of this, some of these axes so it doesn't get to F. I believe you understand what I meant. Okay, so having done this, now the next thing we'll be looking at is the reinforced concrete columns placement. Okay, the reinforced concrete column placement. So we have gotten the Gridline set out for now. So let us maximize this now. We may come back to check one or two things over the AutoCAD plan of the water tank stand. Okay, so with this now we go to columns. So we are considering the circular columns, and what is the diameter of the circular columns that we will be using? The diameter of the circular columns is 250. Okay, diameter. So you come to this provisions section manager and then you click on the section manager right there. So in the section manager reinforced concrete column dialog, we select the circular columns and then over here see the diameter here. So we are going to be using 250 for our diameter. So you just have to key in 250 just like this after we click on the OK options. So we are not having something of this kind. Okay, so we will be having a the tank height is going to be 6,000. All right, it's going to be 6,000 millimeter height. So we have to place one of the columns here. So we'll set the height just for some minutes. Okay, so we have these are the 4 columns successfully placed. All right, so close this. All right, so at this point let us navigate to the 3D and actually see what we have there. So this is what we will be having, and the story height at default is 3 meters. Okay, so let's offset story height. So before we set story height, we will first of all insert a story. So we click on this, right click, and then come to insert story right there, and then you can see default is 3,000 millimeters. So we'll be having altogether to be 3 stories. Okay, so we key in 3 there. The reason why it is 3 is in addition to the railing. Okay, so we'll explain that later. So click on the OK options and then yes options to have this. Okay, so having this now successfully, we can also generate this to the top, but before then let us set the story height. You click right there and then right click on the edit stories. So in the edit story dialog, the story 3 height is going to be 1 meter. Okay, the 1 meter is the length of the railing. Take note. Then the depth of the foundations, we will leave it at 1,100 millimeters. All right, so the structural system is very important. Make sure you always check here. So it's all ROC. Okay, so in case if it is steel, you have to select steel for proper analysis and design successfully. Okay, so click on the OK options right there. So at this point we will be generating these columns up. Okay, so get the columns there selected. Maybe navigate to the populated story, which is the story 1. So we are generating from story 1, okay, to the upper story. So we may not necessarily need to generate because the upper story columns is going to be having a drop. So since it's going to be having a drop, just navigate to the upper story, then get to the plan view of that. Okay, so at that point, click on the column right there. We still have our columns diameter in place. Okay, go to drop right there, activate this drop. So we will be having this drop to be 450 drop, or we, okay, let's do 350. Sorry, that is 350, just like this. And over here we still have 350. Okay, so for the depth we will use 450, or we just consider 400 for the depth of the load. So you click on the center to enable these eccentricities. So click on center, you have an eccentricity just like this. Okay, so with this now we have set all of that for these columns, the drops, and as well as the length of the column. So we just click here and do a window over this 4 intersection point. Release your hand to have the column placed with the drops successfully. Okay, just like this. All right, so this is the top of level 2 we are. You can see it from here. So we can now create our reinforced concrete slab. Mind you, we are designing this using a flat slabs, and then from what we have there, we are considering a slab of thickness 185 millimeters. All right, we are considering slab thickness of 185 millimeter. I click on the slab and I have this that I should set my load cases. So click on the use options. So that is what happened in Protastructure 2022. If you do not set your load cases, you can't be able to carry out your slab modeling. Okay, so let's click on loading generator right there. So we will get this loading accepted. Okay, we are only dealing with a vertical load. It's just 6 meter. Okay, so click on the OK options to apply those defaults loadings factors of safety successfully. Click on the OK options. All right, so at this point now, the program can now permit me to be able to carry out the reinforced concrete slab successfully. So I've been clicking on these provisions, which is not what I actually wanted. I'll get that selected, select this, and I will delete it. I want to have a one single reinforced concrete slabs. Okay, so I will click in these provisions now, slab. So now I have this, and then the height of this is 185. Sorry, it's 285. All right, 185 millimeters. Okay, and then the cover is going to be 25 millimeter. I will go to loadings. Okay, so now in this provision of loadings, we have an additional dead load that has to do with the dead load of the finishing of the slab. So we just call that. So in this case, I will add additional one load of the empty tank, 1 kN per square meter, plus human load of 1 kN per square meters. Okay, which is 2 kN per square meters. Okay, for the additional load. Then for the imposed load, she has to be with the load of the tank. Okay, the load of the tank, but we will be using this for the commercial purpose. Okay, so we are going to be considering with 2.5. Let's use this one. Okay, we use this one for our imposed load, but we need to also add an additional the weight of the water. We will calculate that, and I will show us how we can apply that effectively on the structure. So having key in all of this, I want to go back to the general tab, and then we'll be considering using pick point options of slab insertion. So I will select here pick point options, pick the first point, pick the second point, pick the third point, and then pick the fourth point to have the reinforced concrete slab placed just like this. Okay, so after which I'll close this. Then let us navigate to the 3D to see what we have done actually. So over here, this is what we are having. Okay, so this is what we actually expected. I will be also navigating to the level 1, this level. So we have a beam here. All right, we have a beam here. We wouldn't want this column to be too slender. That is why we have to break it at 3 meters. Okay, so we will be inserting a beam over here, and then select the reinforced concrete beams icon. So we have a beams of 200 by 350, just like this. All right, this beam is not actually All right, it's not actually carrying anything that much. Okay, so we close that. Let's close that. So now we are having this just like this. Okay, the next thing I will show us how to model is the railing on the top of the uh, platform. Okay, so that's to do that, you navigate to the story tree right there, and then at this story tree, just like this, you go to the plan view. All right, so here we are, this plan view. Okay, you just have to, because it's going to be a steel. Okay, so we will navigate to where we have modeling right there. Go to steel. Okay, steel members, and then we'll be considering this the steel columns. So select that over here in the section manager, select that, and then in the provisions, now you are using BS, so we'll be using this circular hollow sections. Okay, so we are going to be considering the second one, this one. Okay, so we click on the select options and the OK options. Then we have this. Okay, so we will be placing this. All right, so we click on these provisions to place that. So we want it to be offset inside. So for you to achieve that, you need to get to these provisions, and then you come here and pick this point, then click on the update. So it has to be updated successfully. I hope it's been updated successfully. So let's place it in this point again. So you have it here. So we need it in the other sector. So you have to use these options. Let's try these options, and then click on the update. You can see it there, right? So let's check this to be sure it is there. So you can see it here. All right, so you can sit very well. The purpose for doing this is for the pole to sit very well. So now I'm having it outside, so I'll come over to these provisions, and then I will use these options this time around and update. All right, then over here the same thing. In this case, I will click here and use these options to update that. So this is what we'll be having over here, just like this. So that is the pole. I'll close that. Let's navigate to the 3D, and then let's see what we are having. Okay, so you can see it there. So with this now, we can now go back to the steel again. This time around, we are going to be looking at the gates. Okay, so we select the gates. Pick this first pole, pick the second pole, and then we have a dialog. We are supposed to have a dialog that will come up just like this. So in this dialog now, you see the spacing of this is okay, the dialog is still loading. Okay, so the spacing of this is 1 meter. We want to make it 200, just 200 spacing, so we can have the horizontal poles arranged just like this. So over here we will be having it to be 100, which is the offset from the bottom. All right, then for the profile, we will change it from this to circular hollow sections. We'll be using that one. Select that, click on the OK options to have this. Then come to sag ground. We don't need this, we don't need this and that. Okay, so we are okay by this. Click on the OK options to have this, but this is appearing at the inner side of the pole, so we have to click on the property to get back there, and then we come to section alignment, and then we want it under the sections just like this. Click on the OK options. Okay, all right, so if you check here, this is still selected, so we can just proceed to doing the same thing. Let's get back to modeling again and make sure we have this selected. Okay, so it's going to use the same profile that we have selected already, so just have to click on the OK options to have that. Okay, so over this side, the same thing, this and that, and OK. So we will have an entrance from somewhere here. So let's get back to the plan of that level. So at the plan of this level now, we need a kind of entrance here. So we are going to be considering this, click on that, and then you click on it property. So we place it here. All right, so we place it here just like this. We want it to be inside. Okay, so it's by this side. We just want it to be at the center, and like this. Click on the update exactly. Okay, close that. All right, so we navigate to the 3D, and then we're able to see what we've done over there. So that is it, this one. Okay, come to still member again, get again. So this time around is to use this and this. Okay, so we click on the okay options to have this. All right, so this now serve as a ladder entrance. Okay, this serve as a ladder entrance. You can see over here. Okay, all right, so having achieved this time around, we'll be looking at the tank stand loading. Okay, the tank stand loading successfully. So we have to calculate the load successfully before we can actually be able to apply it on this platform, before we carry out the analysis and as well design the structural element successfully. Okay, for us to do that, I will also be arranging this in the way that we can also interact with AutoCAD successfully. All right, so here we have a 2,500 liters. Okay, of the, what is the height of this tank? Okay, the height of this tank of this size is always a 2.1 something. Okay, maybe 2.1 or 2.2 thereabout. So we are going to be using the height to multiply by the unit weight of water. Okay, so once you use the height of the tank and multiply by the unit weight of water, is going to give you the weight of the water in the tank in form of an area in square meter. All right, so because you know the unit weight of water is kilonewton per cubic meters. Okay, it's in kilonewton per cubic meter. So by the time you multiply it by the height of the tank, which is in meters, you're going to have kilonewton per square meters, which is an area load we will be applying on this structure. That is the simplest way to get that. But the other long way method, you can check over in my videos. There are other ways to calculate that, which I did on this channel. Okay, so you can check that out. But that's what we are going to be doing. So I will activate the calculators just like this. Okay, so for the tank, for the height of the tank, you have it to be 2.26. Okay, this is in meters. All right, so we are going to use this to multiply by 9.807. Now 9.807 is the unit weight of water. Take note. Okay, 9.087 is the unit weight of water. So for each of this tank, this is the loading in area. Okay, this is the area load. So you click on the equals. You have 22.16382. Okay, which is the area load. So we have 4 of this tank here, 4 of this tank here. All right, so we have 22.16382. We multiply it by 4. Okay, so this is equals 88.655. Let's just take it to 3 decimal places. So 88.655, which is the area load we are supposed to be applying on this platform to use for the design successfully. Okay, so we will minimize, maximize the Protastructure. Right there, I want to show you how to apply that successfully. So over here we have this. We will go to the top of the level 2. Okay, double click right there and then navigate to the plan view of that. Just like this. At this point, now we come to where we have loading right there. Click on the loading and then here we can see here point line and area load. This one, click on it. Then in the dialog, slab load dialog, we select this one. This is it, the area load. So the load magnitude we will be considering is we have so this load is serving as the live load. Okay, because the water will be in and it will also be out. Okay, so it's just like the live load. So we are going to be key in the load here, so which is 88 point 0.655. Okay, 0.655. okay, 65, just 2 decimal places. Okay, 65, just instead of 655, 6566. Okay, like this is okay. So for the G load magnitude, which is the dead load magnitude, we can just take it to be 1. Okay, let's say 1 plus the other one there, we have to be 2, which is for the save weight of the tank successfully. So to now apply this, we can just pick within this area. I can pick from that point and take the load over to this other point. Okay, so I believe the radius, the outer circumference of the tank is within this region. Okay, where my window, where I'm just doing a window now. So we click right there. So here is the load being applied within this area. Successfully close this, and then if you checked it in 3D, you will have something of this kind. So here is the load being applied successfully. So at this point, we are set to carry out our materials settings. So I will first of all save this project. Alright, so having saved this project, now we will be going to the analysis tab. Okay, or we go to the building setout. We come over to where we have materials. Okay, so click on the materials. Alright, so in this material provisions, we'll be using this strength. Okay, this is the strength we'll be using 20/25. Okay, it's a very nice strength. Okay, this one is also good, but this is the one we'll be using. So, and we click on the okay, we are applying it to all. It's already applied to all. You can see it right there. Okay, so for the grade of concrete, we will also be using this 410 grade of concrete. Okay, so we need to select the rebars through these provisions, the rebar diameter. So we are going to set all the necessary rebar diameter we need in this provision. So we will be considering columns. We have columns in the structures. Okay, so for the columns right there, so or you can also check them from here. So once you check it from here, you can see we don't need 10 for the column. All right, we don't need 13, we need 16, we need 20, we need 25. We remove our 32 right there. Okay, so for the column, that is it. Activate the beams. Okay, so for these beams, we have we don't need need this. Okay, just like this. So over here we have the foundations. We don't need that. We can go by 12, but we check here, there is no 12, so you activate this so that you can also check out 12 here. See 12 here under slab and footings, you can set 12. Okay, so after which go back to the slab right there. So what we have here, we remove 8, we remove 10, we have 12, we can remove 13, and we have 16, 20, remove this 2. This is for the reinforced concrete slab. Okay, so we have this 16 here for the foundations, also 20 for the foundations, just like this. Then for the links, we will be using 8, 10, and 12. So we'll remove the rest of that for the links. Okay, so we have set the, let's check the footings. Okay, everything is fine with the footings. All right, so this is how to set your reinforcement successfully. So we have done that. Click on the OK options, and then OK options. This is applied to all of the materials here. Okay, but the foundations and the rest of that. So we click on the OK again. All right, so at this point we will be carrying out some check, okay, on the structure. We will carry out some check on the structure. Mind you, this is going to be designed using the finite element method of analysis to design the slab, and then we will mesh the load with the columns so it can be sent to the foundations for the foundation design successfully. All right, so at this point we will go to the building analysis tab right there, and then at first we will be performing a static analysis, building analysis. Over there, static analysis, you select that on the building analysis provisions. So over here we have already set our materials. Okay, so you come to setting centers. Now why we will go to setting center, so we can be able to set our soil bearing capacity. You can also be able to design this either double footings or single reinforced footings. So we select that setting centers, and then we wait for the setting centers dialog to come up. So in this setting centers dialog, over here at first are the codes that we are using in this design, as you can see. So we come to the foundations right there for the generator. We will be changing this allowable stress of soil. At default is 200. We'll be using 140. Okay, 140 right there. So over here where we have the rebars, top bars inside the plan, we have to check here. They use top bars. We don't want it. You want it to be single reinforced. Okay. Then the minimum footing width is 1 meter. You can adjust this, and the minimum pad base depth is 400. So all of this can be adjusted, but we leave it at default right there. Okay. So having set these two provisions, we are good to go. We click on the OK options, and then you close this first, and then you have to save this project, and then go back to the building analysis provisions. So at this point now, we have already set our loading combinations, and we don't need to apply wind load to this structure. Okay, so we go straight away to the analysis tab right there. So before we carry out analysis, we need to check this structure to see if there is any warning. Okay, so we click on that, and then you will start the check. So you will notice we have a number of errors 4. So it's just like a warning. So if you check, it is overlap. Now where do you have these overlaps? You know, the column dropped, and then the top of platform of the tank, okay, they are overlapping. That is where we are having this overlap, but you cannot do anything about it because it's not going to interrupt our analysis and design. Okay, so that is not an issue. Assuming we have a beam there, it won't have been showing this overlap, but it is because we do not have beams there, so we are designing it as a flat slab or over there. Okay, so close that. That's why you are seeing this error. All right, so we close this window as well. So we click on the building analysis right there. We give the program some time to carry out the analysis. Okay, so in this batch design options, we want the program to analyze and as well as design. So we will check these provisions, or we can leave it unchecked. Then after analysis, we proceed to carry out the check, but we'll check for the steel. Okay, we will check for the steel members, analysis and design. So after which we select building analysis. We have steel, the railing on the platform. Okay, that is the steel aspect of this design successfully. Okay, but before then, let's go and check something right there. So we need to cancel this, and then we close this. Okay, now we will be navigating to story 3. You know, at story 3, what we have here is the steel members. Okay, so we will go to the edit story, and then in the structural system, and then level 3, we change it from ROC to steel. This place, this is what we are supposed to do, just like this. After which click on the OK options, and then yes option. Okay, then save the project again. So at this time, go back to building analysis, and then now click on the analysis. So we check for the steel members design, and check right there. This one we will use bash mode for the design, but we run analysis straight away. Click on the building analysis. Alright, so as you can see, building analysis completed successfully. Yeah. Okay, but it is still loading. Okay. Alright, so the relative story draft satisfy the limit. You can see relative story draft satisfy the limit. You can see, click on the OK options right there. So analysis is successful. At this point, we will go ahead to make sure we close this dialog. Or if you want to see the post-processing analysis, you go to post-processing, and then you can be able to check the post-processing to do this place analytical model. But if you really want to see that, you can close from there. Okay, so here is the analytical model. So if you click here, the analytical model will load up. So here is the analytical model. You can see All right, just like this. Okay, so let's get back to these provisions, and then the analysis is done successfully. We want to design this before we finally design the reinforced concrete columns. We want to be carry out the design of the flat slab, this one. Okay, so for us to do that successfully, we have to go to this FE floor. We click on that. So once you click on the FE floor, you will have the finite element floors analysis dialog, just like this. At this point, you have to reduce the stiffness factors of the slab to 0.25. Okay, after which we will have to let's include the upper story columns load. Okay, so after which we will have to merge the column result with building analysis result. We will do this. Okay, then after we must have done that, we make sure we are at the story. We are at the story 3 because it's going to follow the method of a load chest down from the story 3 to the story 1 successfully. Include column sections in the FA model. Can include that as well. Consider beam torsional stiffness. We remove that. We are not considering that. So click on the floor mesh and analysis. This one. So you just have to click on that. Mind you can as well draw your strips before you do this. Okay, but you can also do it without drawing your strips successfully. And also want to put to us, don't forget to like and subscribe. Okay, and then if you want to more detailed training, okay, we have an ongoing training program on these softwares. Okay, we'll train you to become very good in the use of the Protastructure successfully, as well as Revit structure. So we click on the floor mesh and analysis right there. So that is going to carry out the analysis, and then it's giving us this. Okay, so you have to click on the OK options over here. All right, so it is done with just the story 3. So you have to select story 3, story 2 this time around because it is a load chest down method. Okay, so you select story 2 and then click on the floor mesh and analysis. So you will have something of this kind. These are all the loadings we applied. Actually, these ones are the posts with the point loads, you can see. And the posts are just like a point load, okay, on the slab, you can see right there. Okay. Alright, so we have to close this. We wouldn't want to carry out any other things here, just close it right there. So the last one is the story 1. So you need to also carry the load to story 1, so that from story 1 it will go to the foundations successfully. So click on the mesh right there. Alright, so click on the OK options. So if you check in these provisions, you can see from story 3 and to story 1 has been checked successfully designed. Okay, just like this. Alright, so after we must have done that, if you want to look at the analytical model of that, you can also look at it, but we will have to look at that. So we have to just mesh this just as we have selected and then click on the close options over here. So we are done with the FE floor analysis of this slab, and we have transferred the load to the column successfully. At this point, we need to generate reinforcement for this slab. So we have to navigate to the story 2. Then you go to the plan view. So this plan view now, this is the reinforced concrete slab right there. So this slab, this is the slab. Sorry, I want to select the slab. Okay. We can also increase the opacity of the slab so that it can be visible, you go to the building setup before then save the project. Building setout, and then you come to settings, layers. Okay, you can navigate to the slab right here, this slab ash. Okay, and then you will have to use this one, and then click on the OK options, and OK. All right, so deal with this. Now you can see the slab. So here is the slab now. Okay, it's all right. So the next thing we do is to generate strips for the slab. Okay, so what do you go to the modeling tab, click on the slab strips right there. The slab strips dialog, we are not using the analytical strips because we did it's a finite element analysis that we used, so we use that FA strips selected just like this, and then we click this one, the second one, which is the fixed bound strips, this one, and then the analysis result source is going to be FE analysis, flow analysis. Okay, so after having done that, we now start to place the strips. We pick this point and then take it over to this point and click. So once you click, it's going to generate reinforcement top and bottom automatically, as you can see. So here you have Y12 250 bottom, okay, and then Y12 125, okay, top. Okay, so you can see the reinforcement, but this bound is supposed to be extended to this point and this other point. Okay, but for you to do that is you pick this point and then pick there, click on the update. It's going to extend, you can see, to that point, the same thing to this other side. Okay, then click on the update. All right, so we have this design in the horizontal directions. Okay, so we need to also run design in the vertical direction. So select the Y axis provisions, and then you pick this point over here, take it to this point. So you have your reinforcement in that direction. So we have reinforced the reinforced concrete slabs, the platform that is carrying the tank successfully, just like this. Click on the OK options or close options to close that dialog. And so now that you have done that, let's navigate to the 3D. So we are here in 3D with this. Okay, so if you want this to be more darker, okay, you can still navigate to the layers right there, and then you come down to where you have slabs ash, this one. Let's change this to this one. Click on the OK. Let's adjust the opacity. Click on the OK options. You have something of this kind, right? Okay, let us check the reinforced concrete members to ensure that all of it passed design. So we used these options. So you notice that it's not being designed because we did not design, we only run analysis. So we use these options now to design it. Click on that. We design selected. We select all bars. So we click on calculate. So design is completed successfully. Click on the close options and have it design 6x16. Okay, and the spacing is 175. You can see design successfully. So we close this dialog. We have to check for the beams as well. We do not have beam at this floor, so we go to the story 1 where we have beams, and then we open that. Also use bash design mode, and then we have to select all bars, calculate, and then do you want to redesign default rebars? Click on yes. So you just have to close this to have your beams designed just like this. Okay, now after which we close this. Okay, the next thing we're going to be doing is the foundation design. Okay, so for the foundation design, we are going to be navigating to the foundations, or you can also check these sections to make sure the part design. So you get it selected, right click, and then select team member designs right there. So if maybe you need a report, you can print a report based on this. Okay, all of this as part designed successfully. So you can see, click on the OK options. All right, so for the next thing we'll be doing is the foundation design. We'll now double click on this story 0 right there, and then we navigate to the plan view of the story 0 right there, which is this. At this point, we want to be going back to carry out some settings. On that settings dialog, click on the settings center. At the foundation level, we really want to have a, you see, default part footings form is what? Is a rectangle, so we want it to be squared. So you select here to be squared. Okay, that is the settings. Our soil bearing stress is still the same, 140. Click on the OK options. Then select this now, right click, and then insert part footings right there. So there's a building analysis result are not up to date. You can't continue, but note that the old analysis result will be used. Click on the OK options. So you can see over here we have a square footings just like this, 1.2 by 1.2. If you check the 3D right there to actually look at the design, you can see it here. It is a single reinforced footings. Okay, so click on the OK options to apply that successfully, just like this. So you do the same thing to this. You must ensure that all of the check has passed design successfully. Okay. All right, so here we have inserted the footing successfully. You navigate to the 3D, our footings just like this. So we have to be able to carry out the modeling, loading, analysis, and design of the 10,000 liters reinforced concrete stand successfully, just like this. The next thing that is left with us now is to carry out the reinforced concrete detailed drawings of this project. Okay, so for the detailed drawing of this project, we will be covering that in this next presentations. And so don't forget to like this presentation, don't forget to share as well. Also don't forget to subscribe and stay tuned for more advanced lessons of this kind. See you in the next presentations. Thank you and bye for now.